Well, we've just come in and now we're going to turn on. I usually start with the lights as that one helps a lot. And then there is the ventilation and circuits A and B. These are the technical ones. We can measure here the current and the voltage. The voltage selector switch is line, which is currently at 230. Circuit A, which is through an automatic voltage regulator, 245. B, 24 and a bit. And C is 230 and a bit, which is interestingly, I'll just go back to A, and if you look at that, and I'll turn the fan heater on and off, and it should dip and come back, but as I was bent over poking at the fan heater I didn't see that. And fan heater off. The panel is divided into 4 main circuits, A, B, C and D. Looking at the A circuit, which is one of the technical supplies, it's subdivided into 2 groups. There's the Vision A, which supplies half the vision, and Vision B comes from circuit breaker B, which supplies the other half of the vision. The general idea being that if you lose one of them, you can probably get your picture out using the other supply. And then there's subdivisions again, Vision Mixing Unit A and B, Vision Rack A, Rack 1 and B, Rack 1, and the panel sockets A and B. So there is this division of the power distribution in the hope that if there is a failure which causes a fuse to blow, you can still get by using the other circuit. That's the plan anyway.
And why are there 2 fuses per circuit?
Again, the sharp-eyed will have spotted that there are 2 fuses. Back in 1963, when this vehicle was built, it was the common practice to fuse both the live and neutral lines. Subsequently, we only fused the live line, and in order to preserve the originality of the panel, we've left the neutral fuses in place and they're linked out. They don't form an active part of the circuit, so we are just fusing the line in accordance with current practice. This is a very nice vintage fuse of the period, a 5 amp slow blow fuse, and in the, I'll just hold that and hold it a bit better. You can see the spring there which forms part of the slow blow mechanism.
Yeah. So we have CRT monitors with real signals on them. 405. Would you like me to operate the kludge switch? Go on then. Kludge! There we go. Wonderful.
It's all working. Excellent. Yeah. This is how it should be.
This is how it should be.
I'm astounded that all of those monitors are working.
Yes. Yes.
Well, you made it most
Exactly, that's why I'm astounded.
No, that's wonderful.
They're not without their idiosyncrasies.
Yeah.
Okay.
So that's 405. Is the 60?
No, that is 625.
That's 625, is it?
Oh, okay.
Right, the SPG needs turning on.
Other one. Can we have the right-hand SPG on?
It's a multi-stage progress. So there's a switch on there for SPG 2.
On this one?
On that left panel.
Yeah. This one?
Yes.
Okay. Right. SPG 2. Going to SPG 2.
And now all the switches on the back of the monitors need setting to 4.
To which one?
There's a switch on the back of the monitor. Yeah. Right.
All set to 4.
Oh, it's getting there. Oh, it doesn't like that, does it?
500 meter. 500 meter, Capitan. Keep your fingers clear.
Is that good?
Well, some of them,
rolling like crazy.
some of them are more happy than others. Okay.
Have you operated all the switches?
I don't think
I
one
think
and
so, yeah.
1 and 2 as well. And transmission.
Done all 7 monitors, is it?
Oh dear.
I rather think the SPG needs to be on for a bit
To
to
settle.
be happier, yes.
It's very cold.
Well, the one I was playing has a blocking oscillator, blocking oscillator, trigger blocking oscillator with a transformer in it.
Yeah.
Well, that's looking lovely now.
Swap
Let's
places.
swap places. Let's go to the cheap seats.
You have a go from the cheap seats.
So we're now in 405 lines again,
We are.
and everything
You
is.
can actually keep them far enough apart to count.
You can actually see them.
Oh.
Now, the reason behind all this tomfoolery was the installation of the 2 sync pulse generators back into MCR21. These are the beating heart of the TV installation. Without them, the cameras and the vision mixer simply couldn't function. 2 are fitted in the vehicle. They could be configured as either a main and a reserve, operating both on the same line standard, or, remembering this is the 1960s and dual standard operation was common, one could be left in 405 line mode and the other in 625 line mode. Now, changing between those 2 standards was not a simple affair. It's not a question of just flicking a switch. Several of the internal boards need to be swapped out. For that reason, there's a rather nice wooden box that contains a selection of cards which you would delve into to swap between the 2 standards or repair a faulty unit in the field. This was quite a complex repair. You can see that there was a huge number of components that needed to be replaced. Lots of leaky capacitors and dead germanium components. And Len, our volunteer, has done a sterling job in getting both of these units back to factory fresh condition. Now, in practice, the SPG, although it can free run, needs to be locked to a source of external reference so that the output of the vehicle can be cut to seamlessly.
Now, the sharp-eyed amongst you may have spotted this piece of paper here stuck to the front of the monitor stack. That's the only reference we've got to a unit which helps to lock the vehicle to an AC mains source. Now, locking was always difficult, especially in the early days. This is pre-synchronizers, pre-NatLock. All you have is the national grid. And strangely enough, this can be used as a reference because at that time it was largely all joined together and the phase of the 50 Hz in television centre was much the same as the phase supplied to the outside broadcast band. And with this you could rotate the ganometer control there to change the phase of your SPG, speaking on the telephone to presentation. They will guide you in on a left a bit or right a bit as required. We've yet to make it. Job number 489,356C. Now, one of our trustees, Ginge, has set to and made a printed circuit board with vintage components which will simulate how this works. And at some point we will construct the metalwork and mount the printed circuit boards behind it because we've no idea actually what the back of this unit looked like. So my view is we can make it up as we go along. Well, we tend to do that anyway, don't we?
So here we have a cardboard box, and within the cardboard box there is one circuit board, power supply, and one of these. Synchro resolver.
This is the thing for the ganometer.
Yes, field phasing unit, using tiny germanium transistors from the period.
That's very neat, isn't it?
The rest of the components are more modern, but they're more likely to work and carry on working. But the transistors are perfectly lovely, especially that on the OC28. Isn't it
Is
nice?
this your design and boards and
I just got
everything?
bored and I thought, oh, let's make it
Fantastic.
single-sided.
So what does it actually do for the uninitiated?
I need to set it up to show a demonstration, but I can show it working in a minute. But it generates a 50-cycle sinusoidal waveform, which you can derive from the mains at the same frequency of the mains, but you can vary the phase of it with respect to the incoming mains. So you can lock your scanner to the incoming mains and be of the same field phase as television centre or wherever you're going into.
This is the gadget that Ginger's made to simulate the ganometer unit in MCR21. This mag slip here will change the phase of the output waveform, which we're going to look at now on the scope. And as I rotate the control, you can see that the output waveform there is changing in phase, and the phase of this can then be used to lock the SPG from which the field reference is obtained. One of the problems with a television service which is national and has remote inputs from some far distant field is that of phasing the remote signal to the local television signal. If you don't phase it correctly, there'll be a crash cut and the pictures will roll. So fortunately, the national grid at that time could be used as a reference for phasing, because it's all joined together. One bit of 50 Hertz in London is the same phase as another bit of 50 Hertz in, I don't know, Manchester perhaps. So by using a mains reference, you can adjust the phase of your outside broadcast output to match that phase of the television signal when it's received in London. Now, if you've liked this video, we'd be very pleased if you would use the like button and perhaps also subscribe. This really helps our visibility in YouTube. And then there is also our new website, the Trust's website at bttt.org.uk. We're still building this, so over a period of time we will add more and more information to it. There are also links on it to go to the MCR21 website and the Broadcast Television Camera Museum's website, both of which I'm sure you'll enjoy.